Okay. Hi. Welcome to this video, which is an overview of the second lab in Astronomy 1, Physics 141. In this lab, I'm covering kind of a tutorial for the program Stellarium. And it's really for those students who are already able to run Stellarium on their own computer, and using this lab as kind of a proxy to complete the assignments, or those that kind of want to see me kind of touch upon some of the steps in the lab before they do it themselves. Now, Stellarium is a free open source planetarium software, which can display the night sky for different times and location. It kind of is a surrogate for us not being able to do any kind of nighttime observing for the online classes, and even for my traditional classroom, we are kind of limited in terms of to one telescope. That's a 4-inch Casio-optic telescope. We can see quite a bit in terms of the moon and planets, but it doesn't allow for really a lot of detailed nighttime observing labs. With this program, kind of displays the night sky on your screen and is a good substitute. There are many planetary softwares out there. I've heard of Starry Night or Redshift, or The Sky. It's another old one. But this one I've selected because even though it doesn't have as many bells and whistles as Starry Night, it is free. Runs on many different operating systems. Is easier to use. And is also, I think, a little more photorealistic. Kind of what is displayed kind of matches what you'd see if you were at a given location under nighttime conditions. Now, to get your program, again, kind of follow the steps here. Pull up here. The website is stellarium.org. And again, they do have quite a bit of options in terms of downloads. Most likely, you're going to want to pick, if you have a modern Windows system, pick 64-bit, a Mac, Mac OS here. They do have a web-based one, but it really does not have everything that we kind of need for the lab. So that's kind of only a last. How to say this? You can use that for just kind of general observations, but for most of the labs that use Stellarium in this class, you want your own download. And I think with the Mac, sometimes they don't allow, or it's a setting that prevents third-party downloads. You might have to disable that to actually run that on your computer. So you click on which icon corresponds to your operating system. Downloads. If you have Windows, it's probably going to be in your download section. What you want to do is click on that file, and it will run it, and generally will install it in the directory under your program files under Stellarium. We'll also produce a Stellarium icon, which if let's see. Okay, so I have two versions of it on here, but this is what I want. So just click on that, and it is going to take a minute to run. And here we go. We have now a field of view, this kind of this artificial setting for horizon. That's what I mean. It's kind of photorealistic. The moon's up right now, even though it's trying to turn the day. And as we'll see, we'll go through some of these controls and icons on the left and right here. So first thing I'm going to do first, from my point of view, is kind of fix the sharing, so we're only seeing Stellarium. Now I can minimize it, or not minimize it, exit full screen mode, even though you'll be still seeing the program covering the entire screen. But usually we'll start up in full screen mode. Okay. Now, if you look on your instructions, starting with part B, it'll go through the different toolbars and setting a stellar the way you want it. So kind of turning on and off certain settings is all located along this lower bar. And let me get off the move for a second here. This is here. So right now I already have a few settings of mine. It's set for Williamsburg, where I'm located. So you might have to change that for depending when you start it up, because when you install initially, I believe it's set for Paris. But you should see our icons limited here. Let's turn off. First step, turn off meteor showers. We're not studying them, so we don't really want to worry which directions they're coming from. But if you are curious about that, they do indicate that during times of the year. We've always talked about full screen, which is the square box right here. I'll just zoom in and out. Now, with this program, I know a lot of people use laptops. I do recommend using it with a mouse. You can kind of use everything by keyboard. There is a bunch of settings under question mark. So you want to zoom in with just keys. That's the page up, page down, left and right, a lot of control, something else. But that's just using your keystrokes there. I find it easier to use the mouse, be able to hold a left or a right button down, particularly when we're making measurements. Okay, so that's one set of stuff we can turn on. Let's look at something else. On the left side here, if I drag it all the way to this left corner, there are some more options. These can open up other windows that allow me to control or change certain settings. Configuration menu. Here, controls certain displays. We'll talk about information in a little bit. This indicates whenever you click on an object, kind of what things will be displayed for it. You have some extra things if you want certain labels or certain formats adjusted. Changing the time to format, tools, scripts, and plugins. Now, for this lab and the next lab, you will need the angular measurement plugin turned on. So the lab instructions ask you to do that. So just go to Angular Measure, click on this, and hit load at startup. Now, if it's already checked, it should be fine, and you should have this wonderful icon right here that allows me to make angular measurements across the sky. If not, you will need to check that load at startup and then reboot, basically get out of the software and then turn it back on. When you restart the program, it then will activate, and this icon will now be available. And that's usually the case if you are changing the icons out here based on plugins. But if I do have it active, I can go and stretch. I'm going to measure the sun from the horizon. This will tell me we're accurate here. So right now the sun looks like to be about 34 degrees above the southern horizon. So that's how to read that is degree mark, arc minutes, and arc seconds. And as we talked about in class, those are just kind of smaller angular units. Every degree can break up into 60 arc minutes, and each arc minute can break up into 60 arc seconds. We often use that to kind of find angular distances between two objects or the horizon or another point like the North Celestial Pole in a celestial object. Okay, so the next thing is go back to our configuration window. Do that by clicking on the wrench on the star or the I believe F4 function 4. And here we don't want a lot of information. We just want a few things for this lab. So I'm just going to turn on, do customized, have name, catalog name, number, altitude, azimuth, visual magnitude, type, distance, and constellation. Just those. As we actually have that, exit out. Should be now active. Okay, so the next thing we're asked to do is, I'm sorry, let's go back into our information. And then let's go to the extra tab and make sure we have show asters and lines and boundary lines. Okay, so the wording might be a little different on the lab instructions. The additions have slightly changed, but still, you want to be looking for these kind of first three here: constellation boundaries, lines, and labels. Okay, part C: setting an observation location and date. So let's look over to the left vertical bar and find the location window. A window will appear showing the current location. And I'm going to change it to match the instructions. So if you type in a location here, this will allow you to change. So you can put the Paris Observatory or Paris, Western Europe. That's probably better because we are going to ask for its latitude and longitude. And as you can see that our icon has moved from Virginia to Paris. And when we do that, even if we click around, put on different locations, you'll see that the latitude and longitude do change. So I want you to go ahead for question 1, write down the longitude and latitude for Paris, France. It's listed in this location window. Okay. So now with that, we're asked to change the city. So let's go instead of Paris, let's go to Boston, Massachusetts. So Boston, North America. You'll see here. And then from there, you'll see that our latitude and longitude have changed. Please list that now. So these two guys here. So this is how you can kind of change your location. Again, you can also directly enter in any of these values, click on them. Or if you want to click on a location on the earth, relative, like Brazil, South America, Australia, or again, type in a specific location, they'll let you do that. Okay, so let me go back. I think it's needing you to be in Boston here. So okay, now the next instructions have us kind of look at time controls. So if you notice here, this thing is going at 1 second per second here. Today's date and time. You can control that and change that. And a lot of this looks like what you'd see classic DVD, VHS controls with kind of play, fast forward, pause, or slow motion, or reverse. I can pause time there. The icon's next to it. Doesn't really give you a good specific amount of how fast or slow some of these go. The more you click it, either fast forward or rewind, faster it will go. And then clicking on the center will always bring you back to the current time. Okay, right. Sorry about that. So to get back on what we were doing, we are now looking at step 11 here, and we are asked to change the time. So we have the time controls, and we can go in here and let's see, you go to a date and time window here. We're at 5. And then from there, we can actually adjust the date and the time to match what we want. So here we're going to go back a year to January 1st and go to midnight. So okay, so yeah, your settings, depending on how you have them set up, will either be military time, sort of with midnight being 00, or AM, PM. And I think you can adjust that. Just got to go configuration window, time. And do 12-hour format. You go and do that. It should correctly read that at the bottom. Okay, but in the case of, again, in this setting, it's kind of 0, 0, 0. So from there, we can pan across the sky and change the view we're looking. So hold left with the left mouse button, drag in that direction to shift your view. I can also zoom in and out by using the page up or page down, or if you have a mouse that has a third mouse wheel. If you do zoom in, you might notice that different stars are essentially labeled or not. Another way you go around is hit Shift and then N, S, W, E, or Z for the 4 compass directions or your zenith. It will move it there. So here we're looking east. Where the E is the horizon. Z would be directly up. North is going to be N here. Okay, and if you notice here, if I look directly north, but the similar altitude as the latitude for Boston, you're going to get the Polaris North Star. But from here, I'm going to move around, and we're asked to look for Procyon. And I mentioned that kind of in the first couple lectures. This grouping of here stars, very easy to see in the winter. Looking south at moderate times. They rise a bit. Again, the stars rise easier, earlier, every 4 minutes or so. So by this time, January, February, you're taking this course during the spring semester, you can be able to see these stars kind of in the evening. Now Procyon here, if I click on it here, it gives me some information. The Procyon is the smaller of the dog stars, with Sirius being part of the big dog, and Procyon being the little dog that are the hunting dogs of Orion. And put a little constellation arm up there. You can see here the Orion, big dog, little dog. And there's actually a constellation in between Canis Major and Minor. You saw there. Monoceros, which is another for unicorn. Okay. So with that, you see a couple stars here. In particular 4. What I'd like you to do, list those 4 stars as an answer for question 3. They're in the same field as Procyon. Okay. All right. And I've still clicked on Procyon, so this leads to step 14. So the information listed there is magnitude, brightness, its current direction in height from the horizon, that is azimuth, and altitude. So those are listed up here. So what I'd like you to do is kind of record those. It also lists kind of how far away in space it's located. So that's also listed in light years under distance, with kind of plus or minus error in terms of any type of uncertainty in measurements. Okay, so now we should also be able to find the moon. Go a little further to next step, 15. We're asked for question 5. Look on the moon and write down what is the altitude and azimuth of the moon. Well, we do that. And you should be able to clearly see that within kind of the blue text here. And we also see the listed distance. Now, because the moon is within the solar system, we're not going to be using light years, but we have actually units of astronomical units, which is AU, and then kilometers, which is KM. For this question, for the distance, the lab is asking for the kilometer number. Okay, so now with that, I can do some measuring. For the next step, I'm going to use the angular tool to measure the angular distance between the moon and Procyon. So let's get that there. So click on our angle tool there. Now, if you click on the moon, it should snap to its center and then drag her on to Procyon. You can see there it is 42 arc minutes. I'm sorry, it's let me go the other direction here. It's a little hard to see. It's lost some of the colors. Lost there. Okay, all right. So in the center. Okay, try it. I'm sorry, 21 degrees, 37 arc minutes, and 57.18 arc minutes is what's displayed. Sometimes you have trouble kind of seeing that. You might just have to shift and do your measurement again. So you actually see those numbers there. And this, I can round it. You know, keep in mind when you're rounding to the nearest degree, there's only 60 arc minutes in a degree. So if it's 30 or more, it's rounded up. If it's 29 and 29 arc minutes and some arc seconds, round down. Kind of like the same thing as you round as the nearest hour. Okay, so that's how to do an angular measurement. You'll get a chance to do a lot more of those in the next lab. The next thing is to let's do some displays. So down here we have kind of constellation lines, constellation labels, constellation art, boundaries, asterisks and lines, and asterisks and labels. So let's figure out where, in terms of constellations, what boundaries these guys are. So here, Procyon, of course, is stuck in Canis Major. Here's the original stick figure view. It's actually just like a line connecting two bright stars. Not much of it. It's more like a bone than a dog. But in terms of a modern constellation, which is this entire boundary here. So the constellation that Procyon is in, and then I can see the moon as well. Moon's over here. The constellation name listed in blue. Now, of course, the moon drifts compared to the background stars. So if I go forward another night, it's going to be most likely in a different constellation. Okay, so that is step 17, question 7. All right, next thing we're asked, well, step 18, kind of pan around, maybe use your compass keys to see if you can see other bright stars and other celestial objects. Are there any planets around? Well, zoom out. The answer is yes. Yeah. Mars here in the western horizon. Okay, so that's a little bit about some of those controls at the bottom. Okay, later on you'll this lab you'll use some asterisms, which are again they're connections, more modern connections of bright stars that are often useful because good for navigation, such as like the Big Dipper, or they just happen to be clutches of the brightest stars. You usually always be able to see them if you have reasonable clear skies. But let's take a look at the next step. D is time controls. So again, our controls are on the bottom here, the lower right. So again, we can have rewind or decrease time speed. You have set normal time, go to the current time, or if you double click it, just else as well. No, not that. It's this one. And of course, we have fast forward. So I'm sorry, pause and then play are the same button. All right, so let's just stars move on their own this time. So if we look to the west here, okay. So question 9, how do the stars appear to be moving if we look to the west? Okay, well, enough information for that. Pause. Okay, so step 20, pause the time controls, and with the time date window, we set the time to 12 a.m. So I'm going to go back here, and let's go back. I'm going to show you because I think I accidentally hit the button. Go over to now. I'm just going to make sure I'm on the correct date. And with that, click fast forward, you see the star shift. Okay. Let's take off some of those extra ones again. Okay, so we have stars in the west, how they appear in the south. How they appear to rise from the east. And finally, looking north here. We'll zoom in a little bit. Or zoom out. See a little dot here. Okay, so from that, and let me go reset back to night here. Okay, so how do stars appear to be moving from this view here, from the north? Okay. Pause again. Okay, so reset it. And go again from the east. Okay. Let's see how they appear to rise from latitude Boston. So see that they're not going perpendicular from the horizon, but going at an angle. And we'll see next week's, well, not next week, but a future lab that deals with celestial spheres. There's actually a connection between the angle of that they rise at and the latitude you observe it from. Okay, so question 11, do eight planets rise above the eastern horizon toward the sun? Okay, so we're going to look carefully here. There we see one planet there. Okay. So record that for your answer for question 11. And then finally, I'm going to go a little slower here. Trying to catch the sun right when it's rising. And as you can see, you can easily make a mistake. if you hit that set time to now by accident. There we go. So let's use that for our time of sunrise. For okay, yeah, you run it in there a minute there. But sunrise for January 1st, 2021 from Boston. Okay, so we're almost done. Last section, finding objects. So let's shift this to the following midnight. Okay. Now the moon is in a different position. So we zoom out here. Okay. Look at our friends. Betelgeuse, Orion, Procyon, Sirius. I'm gonna put get lines gone and boundaries back in. Okay, so before the moon was in Cancer. Now we've gone the one full day later. We see now the moon has shifted compared to the background stars, and is now in a different location, different constellation here. So record that. Let's see. Now, if we wanted to find the moon, we didn't know where it was. We can use the search window here, which is the part of the lab here. You can just type it in, click it, it will take it to that object. And while you see those kind of rotating red crosshairs, that object is locked. So your field is locked on that object. So if the moon does drift as you move time forward, the program is going to try to keep the moon in the center of your field. That's very important. If you try to advance time, you don't have a locked on an object, it will stay looking in that direction, but stars will come in and out of your field of view. In the field of studying one object, you might not have it anymore, especially if you're zoomed in. Let's just like go all the way in. Let's see here, we can look at close-up features of the moon. All right, so now next step, 23, use the search window to find the location of the star Capella. Okay, so you see everything kind of shifted all the way over there. The Capella, if I move out, we find that we see Capella there. Okay, and it's in a constellation, actually the brightest one of Auriga, which is the Chartier, I believe. Let's see. Constellation art. I'm sorry, no, the Herdsman. I think Booty Tez is the other one, the Chartier, which is another northern constellation. Okay, so with the phone here. Okay, so back to the step here, we have Capella. Now let's try to find Jupiter. So again, search window. And it looks like Jupiter is below the grass here. If we look at its altitude, it's actually got a negative. So right now, Jupiter is would not be visible because it's below the horizon. It's on the other side of the Earth at this current time. Now, the great thing about planetary software like this, it does allow you to kind of remove things that you really couldn't do in the real world. And one of them is the Earth itself. So we can get rid of fog and the ground, and lo and behold, I'm going to actually be able to see through the Earth. And you actually see that Jupiter and Saturn are actually pretty close together here on that date. And then I can see it, and you can write down now it's latitude of minus 62 degrees. Okay, so hopefully this will help a little bit see some of the options you can do with Solarium. You'll do a lot more in Lab 3, looking at a wide variety of constellations and asterisms, particularly using the Big Dipper to find other objects in the Northern Hemisphere, or the northern portion of the celestial sphere. Now with that, again, you have to have a lab report with this lab. So with that, example of a lab report is within the lab section. You should have an introduction stating the purpose of the lab. One or two paragraphs after that in a procedure section, which is a summary of the steps you did to complete the lab. Shouldn't be too long for this one. And then finally, you have data and discussion, which is usually anything you've recorded in the lab, any graphs, any tables, be under data. Discussion would be any analysis of your data, as well as any lab questions. For this one, both sections is really going to be your 15 questions answered from the lab. And then finally, you have a conclusion paragraph where you have you can post whether you met the objective of the lab, it meets purpose. In this case, you find Solarium easy to use or difficult. Would you recommend it to someone else if they wanted to kind of look at some stars and see what's up in the night sky? Did you learn anything about Solarium from this lab exercise? And in the labs, if you have kind of sources of error that might cause measurements to be off, that's a section, the conclusions section where you want to include kind of some of that information. Okay, so this is going for a little bit, so I'm going to stop it here and hopefully record correctly to the cloud. If you have any questions, just please let me know by email, or if you're in my traditional class, talk to me in class. Thank you.